Okay guys, let's try to do some more questions on partial derivative. Let's look at this one, which is question number 2. Okay, question number 2 here. What is all of the partial derivatives of exponent to the power of negative x squared minus y squared? Right, we start with the partial of this function with respect to x. So by default, the way to differentiate exponent, right, is to bring the power to the left hand side and differentiate it. That is the common way we did it before in the differentiation. But somehow for this one, when dealing with partial derivative, as we have discussed before, we need to focus on x, right? For this one, we need to focus on x, and y will be considered as it is not exist, right? For the case of subtraction and summation. Okay, so basically this is how we write it down, right? I just bring down the power, and we just will differentiate on the x, right? Sub minus y squared. Y squared here we consider not exist. Okay, so we will get negative 2x times with the exponent. So we get negative 2x exponent to the power of this, right? So the next component that we have in derivative, of course, y, but let's try to in order. We already have x here. Let's go for the second derivative of x. To do the second derivative of x, please notice that we have actually the product between two things here. We have negative 2x times with the exponent. So because we have a product here, we are going to use product rule. Of course, by using uv prime plus vu prime. So let's define u and v. So by default, we are going to say negative 2x is the u, and this exponent will become the v. And after that, we will be looking for the primes. So u prime is a negative 2, right? And for v prime, right, we are going to differentiate v, right, because we are now talking about x. So v here will be differentiate in terms of x. So by right, we should get the same answer as the first derivative of x, right, which is this one. So the next thing to do is just to substitute it, right, and simplify it to get this answer. Okay, that is for the second derivative of x. Now let's go to y. We do the same thing as what we did before, which is differentiate the exponent, but now in terms of y. It means that we are going to differentiate y rather than x. So we consider this not exists. Alright, so for this one, we become negative 2y, right? Negative 2y exponent to the power of this. Okay, now for the second derivative, again we have product rule here, so we are going to use the formula of product rule. Define u and v. So we have negative 2y as u, v is equal to the exponents, and differentiate it in terms of y. So negative 2 with, again, it should be the same as the first derivative, and then substitute it in the formula, simplify it, and you have the second derivative, second partial derivative. Now we have already done 4 components of partial derivative. We have x, y, and their second derivatives. Now let's go for the last one, which is the last two, which is mixed partial derivative. Now notice that the terms, the notation used for mixed partial derivative, right? It start with the partial of second derivative. Okay, meaning that there is no mixed derivative for the first derivative, right? So basically, the second derivative, if we mix it, for this case, we first derive conduct derivative for x, and the second derivative will be on y. So basically, what it means here, right? The first derivative is on x, which is this one, right? We should get this on the first derivative. And secondly, the derivative was conducted on y. In other words, we are going to use this derivative, which is x on x, and later derive find the derivative in terms of y. And because of it contain a product, the product of two components here, negative 2x times the exponents, of course we are going to use the formula of product rule. It is almost the same as when we conduct the second derivative of x before, right? However, for this one, instead of conduct the second derivative in terms of x, we use this function to conduct the second derivative in terms of y. So for u here, as you can see, it is negative 2x. There is no y terms here. So when we conduct a derivative, it is 0. Right? It is 0. If you are not really clear on this, you can just assume it like this. This is just like negative 2x plus y to the power of 0, right? Where we will ignore the x terms, right? And we will proceed with differentiating the y terms, where of course it is actually 0. That is if you are not really clear on how I get 0 here. And then we have v, and we are going to differentiate it in terms of y. And by right, you should get the answer here, right? That should be the same with the first derivative of y here, right? So next, let's substitute, and this is the answer. And lastly, we also have the mixed partial derivative, that is actually y to yx. Right? For this one, is start from x and then y, right? And right, the idea is almost similar, but now instead of using the first derivative of x, we are now using the first derivative of y. And you know, we just define u and v, differentiate it in terms of x, substitute it, and get the answer. Alright, for mixed partial derivative, you should get the same answer. For partial y to partial x and partial x to partial y, they should get the same answer. Right? The step might be a bit different, but the final answer should be equal. Right? That is for this question. Let's look at other questions if you have any. Yeah, this one. Let's look at these two. We are just going to discuss this quickly. Okay, partial x, right? Meaning we are going x, y, and z here, right? Other than x, we will assume it as a constant. Right? So just a little bit of revision to differentiate trigonometry. if you have a value here, a constant here, this constant should be differentiate on the left hand side. So meaning that I should bring x, y, z to the left hand side, and then yz will be treated as a constant, so I pull it out from the derivative. I just derive x. So x here will become 1, so it will become yz. As for sin, of course, sin become cos. That is how I get yz cos x, yz. And then for the second derivative, because yz times with cos x, yz, alright, we should conduct product rule. So for the product rule, yz here, there is no x term, so 0. For cos x, yz, if we differentiate it in terms of x, right, again, x, yz will leave us with yz, and cos will become negative sin. So substitute it, and this is what you should get. And go for y, we do the same thing. You should get x z times cos x, yz. Look for the second derivative. You should just do it like this, right? X z, derive it, right? There is no y term here, so 0. As for this one, if we derive it in terms of y, you should leave x z with negative sin, so you get negative x z times sin x, y, z. Substitute it, and this is the answer. And then for the mixed partial derivative, for this one we start with x, so we should use the first derivative of x, right? Conduct a product rule. So yz, and we derive it in terms of y. So yz, we have y here, so y become 1, and z is a constant, so that leaves us with z. And then for cos, right, we get xz with negative sin. Substitute, and this is what you get. And for the mixed derivative of y to x, so we use y, first derivative of y, and we proceed till the end. And you should get, as you can see, for the mixed partial derivative, they should be the same. Okay, and for the next one, let's look at B. Alright, for partial x, again, this is exponent, so bring everything to the left hand side. For y and z here, we consider it as a constant, right? We just derive x, so it become 1, so that will leave us with y squared z to the power of 3 times 3 exponent. So this, we will get this. And then for the second derivative, as you can see, we have the first component 3y squared z to the power of 3 times with the exponent, so we will conduct product rule. Okay, this is what you get. Okay, substitute, and this is the second derivative, and then we have y, right, with the second derivative, and we have the mixed partial derivative, right, where you use, for this one we use x, the first derivative of x, and we proceed with the partial derivative in terms of y. Right, we get this answer. And for the second one, we start with the first derivative of y, and we solve it using the derivative as partial derivative in terms of x. This is the answer. And again, the answer of this, the first mixed partial derivative and the second mixed partial derivative should be the same. Right, that's it. That is on the idea on how to conduct partial derivative. Thank you.